My name is Flash Isaac, and I'm a teacher from the future. Hello, you are welcome to episode number 65 of the 120 Days to Jamb Physics with Flash Isaac. We started from the bottom. I think we are progressing. Look at this. If you watch my episodes under mirrors, when we got to concave mirror, or for concave mirrors, I said that the image is formed depends on the object position. And when we got to convex mirrors, I said that the images formed are virtual, erect, and diminished. Which means for convex mirrors, the images to a large extent do not depend on the position of the object. And these images are formed between the focus and the pole. Let me repeat. While discussing images formed by curved mirrors, I said that for concave mirrors, the image that is formed and the position of the image depends on the position of the object. And I gave different object positions and where the images will be formed. Please, if you've not watched that video, you don't have any business with this episode. This is a series. So if you skip any episode, you don't have business coming forward or any business saying you don't understand. You must follow from episode 1 and follow them straight for you to understand. If you miss any episode, you will not understand. I treat the class in such a way that no stone is ever left unturned. I treat everything. If I see some things I didn't say in the previous episode that I should have said, I think about it and say them in the next episode. So it is sequential. Everything is covered to avoid confusion. So if you don't look at all the other episodes or the mirror episodes, please, you don't have any business in this class. And if you looked at them and you don't understand, please go over. This is serious business, very serious business for you to understand. So what was I saying? For concave mirror, the image is formed. They depend on where you place the objects. And I said that for convex mirrors, the images formed are virtual, erect, and diminished. And they are usually between the focus and the pole. Lenses, on the other hand, is inverted, vice versa. Vice versa. What do I mean by inverted? For concave lenses, on the other hand, for concave lens, the images formed are virtual, erect, and diminished, and they are between the focus and the lens, or the focus and the pole. Concave lens is having characters of convex mirrors, and for convex lens, the images formed, they depend on the position of the object. It is where the object is placed that determines the position of the image. What does that imply? Convex lenses are not taking the characteristics of concave mirrors. So look at it this way. For concave mirrors, the position of the image is determined by the position of the object, and the nature of the image also takes that. And that is also true for convex lens. So convex lens and concave mirrors, they do the same thing. They have the same characters. Meanwhile, concave lens and convex mirrors, they have the same. So anytime you hear concave mirrors and you hear convex lens, know that the image formed in both of them depends on position of object. When you hear concave lens and convex mirrors, they have the same characteristics of the image. They are virtual, erect, and diminished. What does that mean? The calculations for concave lens and convex mirrors will be similar, and the calculations or formulas or signs for concave mirrors and convex lens will be similar. Please take note of that. All that being said and done, what happens in a convex lens? Convex, when one image, no, object is at infinity. When object is at infinity, it means they are far from the lens. Object at infinity means it's far from the lens. So what happens? To draw the image, and even for other position, this is what you do. Since they are in position, draw rays parallel to the principal axis. This is the principal axis. It is an imaginary line drawn like this to cut through the center of the lens. This is the principal axis. So ray parallel to the principal axis means straight rays. The object is now at infinity, but behind, around here. This is where the object is right now. So before I proceed, let me basically highlight all these ones and clear them. Uses of concave and convex lenses. Convex lenses are used for magnifying glass, they are used to make microscope, and they are used for spectacles to correct vision. Convex lens is used to correct short far-sightedness, long-sightedness. Concave lens, on the other hand, is used to make flashlights. They are used to make spy holes in door. If you see some doors, you see small hole inside that you can use to peep. So they are used to make spy holes in doors. The images are diminished, small, virtual, and erect. And they are used to make spectacles. In this case, to treat or cure myopia, short-sightedness. So for short-sightedness, use concave lens. For long-sightedness, use convex lens. Exam questions. Long-sightedness, convex lens. Short-sightedness, concave lens. Convex lens for magnifying glasses for microscope. Concave lens for flashlights, spy hole indoors, and spectacles to correct myopia. So if object is at infinity, you draw a parallel ray like this. This is like center of the mirror. It comes here. You draw another parallel ray like this. You draw one like this. You draw one like this. So they both have to get here. So by the time they get here, what happens? They cross the focus. So this goes like this. This goes like this. This goes like this. This goes like this. All the rays passing through the, since all the rays that are parallel to the principal axis pass through the focus here, the image is formed at the focus. These rays parallel to the principal axis, they all cut across the focus. So image will be formed at the focus. So image is at focus. Image is at focus. And this image formed is real, inverted, and diminished. So for a convex lens, When object is at infinity, which means when they are placed far away from the lens, the image is formed at the focus f2 here. Let's say what happens when object is beyond focus. Let's say when object is beyond focus, these two beyond this second focus, what would happen? So these are basic things. It will be very good if you learn the diagram. They are not even hard at all. They are simple to learn. But if you don't want to learn the diagram, you just need to pass exam and objective exam. Simply just cram or understand what happens. That when object is at infinity, image is at focus. That's if you don't want to, if you just want to cram and pass. It's your choice. I give some persons like to understand concepts, some like to just know that okay, this is what happens, this is what happens. Any category you belong, there's something for you. If you belong to the one that just want to know that when object is at infinity, image is at the focus and the image is real, inverted and diminished, fine, we have food for you. If you are the one that wants to know that how is this formed, we have food for you. So object beyond focus, this is 2f, so the object is here like this. This is what you do. First of all, you draw a ray that is parallel to the principal axis. Let me the image. A ray parallel to the principal axis. So it comes like this and ends here. It is parallel to the principal axis. And all the rays parallel through the principal axis must pass through the focus, like we did earlier. So since this ray is passing through the principal axis, is parallel to the principal axis, it will go down through the focus. This is focus F2. So it comes here like this, like this, like this. That is one. Step 2, you draw a ray that cuts across the optical center. So the ray from the object going straight through the optical center. So it goes like this, straight, 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 like this. Pardon, let me try to draw something meaningful. Like this, like this. So this is the idea. If the diagram is correct, right, it's like straight, this is straight, you definitely know that if you have a sphere like this and they have an object here which goes like this and through the focus, if another one is drawn straight, the two will definitely meet around here, which is between f2 and 2f2, between the focus. So the image will be formed here like this. You call here B, you call here A. So what am I trying to say? If object is placed beyond focus 2f1, the image will be formed between image is between f2 and 2f2. Image will be between the two focus, between the two principal focus, f2 and 2f2. So when object is beyond the focus, image form is between f2 and 2f2. And what is the property of this image? It is the same as the first one. It is real, inverted, and diminished. By diminished, we mean that it is smaller than the object. The object appears bigger than the image. So if here is big, here will be smaller if drawn accurately. Now let's see case 3. For case 3, let's say object is at focus 2f1. Remember here it is beyond the focus. Let's say it is now at the focus 2f1. Let's see what happens. The object is here at the focus. Let's see where the image will be formed. The first step, as always, is draw a ray parallel to the principal axis. So ray like this, it gets here. And I told you that any ray that is parallel to the principal axis must pass through the focus F2 or bounce back. So in this case, this one goes here like that. Step 2, draw a ray from the object to pass through the optical center. So we're having something like this, like this, like this. So you notice that these two rays, they meet here, and drawing this up, this is at the focus, B A. So the image is formed at 2F2. Image is formed at the second focus, 2F2. And when image is formed at F2 or 2F2, this is what happens. This is the characteristics of that image. It is real, it is inverted, and it is same size as the object. When image is formed at F2, or image formed when object is placed at 2F, the image is really inverted at same size. Now look at something actually. See, this makes cramming easy for you or understanding easy for you. You simply say that when object is at 2F1, the image is formed at 2F2. So it is real, it inverts, and it is the same size. The size does not change. So to produce same size image using a convex lens, you simply place the object at the focus 2F1. That is the answer. How about when the object is placed between 2F1 and F1? So let's say case 4, object between 2F1 and F1. Let's say the object is here. So where will the image be formed? Step 1, draw lines parallel to the principal axis like this. Then any line that is parallel to the principal axis must pass through the focus F2. So let it go down like this. Like this. You see, I can see you are beginning to enjoy the class. It's basic understanding. Now, if it goes down like that, we draw another line from the object to pass through the optical center or the center of curvature. It goes like this. Now, even from this rough diagram, you can see that we are getting accurate drawing. If this is seen, this is closer to this. Once you draw something like this, it tends to go down like this. It's just basically accurate. Now, where is it formed? You see that it is formed beyond 2F2, back of 2F2 like this. It will be formed around here. That's where it will be formed. So image will be formed beyond 2F2, beyond me, back of or front of. Image is beyond 2F2. That is where the image will be formed. And the characteristic of this image is 1, it is real, 2, it is inverted, and 3, it will be enlarged. Now let's see something. When we say image is enlarged, it's the same thing as saying that the image is magnified. Enlarged is the same thing as magnified. Let's say object at F1. Let's say case V, object at F1. Okay, object is at F1. The image that is formed, first, you draw a line parallel to the principal axis like this. Then it must go through the focus. Then you draw another line from the object passing through the center. So like this. Now, look at something. These two rays They are even parallel to each other. They will go, they may not even meet. So that is like infinity, which means when object is as f1, the image formed will be will be infinity, at infinity. And what is the characteristic? It is real, inverted, and enlarged, RIE, or you see real, inverted, and magnified. Look at something that is making sense. When object was at infinity, image was formed at the focus f2. Now, object is at the focus, image is formed at infinity, inverse of each other. In this case, it is diminished, and in this case, it is enlarged. So let's take a look at the last case for today. VI. Object between the focus f1 and optical center. Object between the focus and optical center. Where will this image be formed? Let's see something. So this is what would happen. The object is here like this. This is the object between the focus and the optical center. You draw a ray parallel to principal axis like this, and ray parallel through principal axis must go through the focus. So this goes like this. Then you draw another ray to pass through the optical center. So like this. You notice something. It's like the rays are spreading like this. So if they are going trending towards this side, they are going like this. It means they must have met at a point here. Something like this. They must have met like this to be able to start spreading. So as such, the image will be formed here. This will be the position of the image. And what is that position? Is basically formed behind the lens. Image is behind lens. And when an image is formed behind the lens, it is basically virtual. It is not real. Real images are formed in front of the lens. So this image is behind the lens. So first image it is virtual. Why? It is formed behind the lens. When image is formed behind the lens, it is basically virtual. Now, this image is erect, and it will definitely get bigger from this back meeting. You know that this one will even grow taller than the main object. So it is enlarged, or you say magnified. And anywhere you see enlarged, magnified, diminished, smaller. So far we see that all images formed by convex lens are real, except when the object is between the focus and the optical center. Exam question. Also, when object is between the principal focus and the optical center, image will be formed behind the lens. So let's have a recap of this class. When object is at infinity, image will be formed at focus f2, and it is highly diminished and point-sized. This image is real and inverted. When object is beyond 2f1, the image will be formed between f2 and 2f2. This image is real, inverted, and diminished, RID. When object is at 2f1, the image will be formed at 2f2, and this image is real, inverted, and same size as the object. When object is between f1 and 2f1, the image that is formed is beyond 2f2, and it is real, inverted, and enlarged. When object is at the focus f1, the image will be formed at infinity, and this image is real, inverted, and enlarged. Now, finally, when object is between the focus f1 and the optical center, the image formed is on the same size of the lens as the object, and it is virtual, it is erect, then it is enlarged. As you can see here, 1, case 2, case 3, case 4, case 5, and case 6. I did my best to make sure it is simple. Please let me know if you found the class interesting, and let me know if you have questions using the comment box. Get the Flashlearners application and play with questions. You are definitely going to find the app very, very helpful. See you in the next episode.